Just notes right now. There's no booklet. I realized I should have put this in the fundamentals. Like I went back and forth. I'm like, no, yes, and then I didn't. But I want it in there. Okay, because electronegativity is such a big long word, we will often abbreviate it EN. Yes, because like it's just so long. And electronegativity is the ability. And if you haven't yet figured out, that's my letter T, because I grew up doing cursive and it just stuck around. Okay, that's a letter T. The ability of an atom to pull bonding electrons towards itself. Huh? Right here. Okay, that's a T. So if you ever see that, that's the letter T. So we're going to take a look at this in some context. Okay, so we have oxygen is very electronegative. Tell your partner what that means if it is very electronegative. So oxygen is very electronegative. In other words, it is very good. I have to make this smaller, otherwise I can't write properly. At pulling bonding electrons towards itself. Hydrogen has a medium low. Electronegativity. i.e., in other words, it is not as good. at pulling electrons bonding electrons towards itself. And we'll worry about why later, okay? For now, this is all you need to know. So then if I take a hydrogen and I bond it to an oxygen, where would the bonding electrons end up? Would they end up, and I'm going to give you three choices. We got a red choice, we got a blue choice, and we've got a green choice. And if you can't tell the difference between those colors, let me know. Huh? Where do the bonding electrons end up? Do they end up in the position of the red electrons? Do they end up in the position of the blue electrons? Or do they end up in the position of the green electrons? Chat with your partner about that.
Yeah, I mean,
Okay, now we're going to vote on this. We're going to do R for red. Okay, when you have R, the letter R is you just cross your fingers. Okay, R. B for blue, you put your fingers up and you put your thumb on your palm. That's B for blue. And then green, this one's a little tricky. You put your three last fingers down and you point your thumb and your pointer finger like that. There you go. And you orient it like this. Which way do we? Yeah, we orient it like this. Can't remember. I think it's like that. Yeah. So that's a G. Okay. So you get to vote red, blue, or green. 5, 4, 3, 2, vote. Yes, indeed, it is green because oxygen is good at pulling those electrons towards itself. So we're going to get rid of those. Okay. And those are our bonding electrons. And they're much closer to the O than the H. Now, if I wanted to draw, are you guys aware that electrons don't actually zoom around the nucleus like this? Did you know that? How many people knew that? Some of you. Okay. Those of you who don't know, we're going to learn about this year. In honest fact, like electrons don't. Okay. If you've got, say, hydrogen, okay, its electron might appear here. Like if you take a snapshot of it, it might be right there. And if you take a snapshot a minute later, it might be there, and then it might be there, and then it might be there. And what you end up basically with is if you take a bunch of photographs over time and you overlap them one on top of each other, what shape do you get? You get a sphere, basically, okay? So that's what electrons really do. They really just zip around. We'll learn they don't zip around, but for now, that's how we're going to look at it. They zip around and they appear here and there and here and there within a specific shape, okay? Now, the bonding electrons between hydrogen and oxygen are going to appear like this, where we have a lot of density over near the oxygen.
So the electrons are still able to move freely.
They still move freely between them, but they spend more time over near the oxygen. What effect will that have on the charge of the oxygen atom? Yeah, it's going to be negative. And that's why when we have water, for example, the oxygen ends up being slightly negative, and the hydrogen, which gets where the electrons spend less of the time, ends up being slightly positive. I don't know why I put a circle around the negative sign. I'm going to get rid of that. There we go. Slightly negative and the H slightly positive. So that's going to explain. Yes, sorry. That is the Greek, this one. That's Greek, lowercase
Delta slightly.
delta. Now let's imagine that we have a hydrogen bonded to a hydrogen. Would we find the electrons at the position where we have the red ones, where we have the blue ones, or where we have the green ones? Think about that. Chat with your partner. Okay, red, blue, or green? Blue, yes, why is that? Tell your partner why, if you had to explain why. Why are they in the middle? Yes. Yeah, they're the same element. They have the same electronegativity there. Therefore, they pull on the electrons with the same strength. Okay, and therefore the electrons are shared equally. and neither hydrogen has a positive or negative charge. So what I'd like you to do, once you've got that down, is to predict what you think that bonding electron cloud would look like between the two atoms. Up here, it looked like we had a greater density towards the oxygen. Take a guess at what it's going to look like down here. Try and draw it. And then once you've drawn it, check with your partner and see if you got the same thing. Once you've drawn it, check with your partner. Ends up looking a little bit like a little sausage in between them. Okay? We have an even distribution of the bonding electrons. No. They just kind of randomly go everywhere in there. Quite frankly, that starts the actual, like what those bonds look like, starts getting into molecular orbital theory, and we're not going to get there for a while. So just go with me, okay?
So we think both slightly positive right now. They're both slightly negative. Or neither.
Yeah? Because their nucleus is positive, and they both have electrons. Now, to be fair, we're not showing the whole picture because there's actually electrons like over here that are bonding electrons, but that's just going to confuse you, so we're going to pretend that you didn't see that, okay? Because it still confuses me a bit. And they're called anti-bonding electrons. Oh my God, like what? It's at a higher energy level, and they will bop up there from time to time. Carbon and hydrogen have similar electronegativities. So what would their electron distribution look like? So you can give that a little drawing. Okay, there is an equal time share of where the electrons spend their time. You guys good with BW for between? So there is no slightly positive end. There's no slightly negative end. They are just all neutral. Is good? Okay. So if you recall, we had our our oil molecule. And I just drew 9 carbons. How many hydrogens would we need to fill up that structure? Tell your partner. Well, every carbon needs one on the top and one on the bottom, yes? Because that's going to give carbon 4 bonds. Whoops, I forgot one here. What about the 2 terminal carbons? What do I mean by terminal carbons? The ones on the ends, yeah? Okay. So terminal means on the ends. So if you come to the bus terminal, it's at the end of your journey. Yes? So the 2 terminal carbons, what do they need? They need one more. So carbon has 4 bonds. Okay, and carbon almost always has 4 bonds. We'll learn later that there are some exceptions to that, but almost always carbon has 4 bonds because it's got those 4 empty spots in it. So in truth, this molecule is not actually an oil molecule. It is actually a really simple form of hydrocarbon. See if you can remember the name of that group of hydrocarbons that we have only single bonds, and it's just carbon and hydrogen.
Okay. Great.
See if you can remind your partner. Starts with an A. Alkanes. So this is really an alkane. It's not an oil molecule, but they behave a lot the same way. And you can imagine oil a lot better, right? You've never seen probably an alkane, right? But you've seen oil. So if each of those hydrogens and carbons are sharing their electrons equally, equal time share, this molecule then, is it polar or non-polar?
So this is why it's dissolved.
What do you guys think? Everybody, non-polar. Is good? Okay. And way back, also on that day when we had the fire bell and all those things, we asked a question because we talked in our class a lot about Coulombic attractions. Yes? Remind your partner what a Coulombic attraction is. Coulombic attraction is yeah, it's an electromagnetic force. I'm going to call it an electrostatic force. Because this actually does not have to do with magnets, although the two concepts are interrelated, okay? Electrostatic, let me see if I can spell that properly. And what do we have to have in order to have an electrostatic force? If we have a gravitational force, we have to have a body with mass and another body with mass. What do we need for an electrostatic? We need charges. Okay, so it's the electrostatic force between charges. And if we have positive and positive, is it an attractive force or a repulsive force? Repulsive force. Negative and negative? Repulsive. And positive and negative is attractive force. So the Coulombic attraction specifically refers to this one. Okay, but if you say Coulombic forces, it would have referred to all of those attractive and repulsive forces. And we left off with this question. In a covalent bond, what are the positive and negative things?
Right now.
Chat with your neighbor about it, okay?
On both sides of it. So it's sections. So I think it's just generally.
So if we have hydrogen and hydrogen, we could represent it like that. Or we could represent it like this, yes? Now, what's at the center of a hydrogen atom? The nucleus. So really what we have is we have a nucleus and we have a nucleus. And if that's all we had, then what would these two things do to each other? They would repel, right? But we know that hydrogen sticks to hydrogen. Why does it stick to hydrogen? The electrons in the middle. We have these lovely little electrons in the middle. Yeah, exactly. Okay. And so we get these little red lines that I do like this. These are usually representing an electrostatic attraction. Okay, so we have and it's between the nuclei and the bonding electrons. Is good? Okay. Do you remember in an ionic bond what the things are that hold the ions together? What are the positive and negative things in an ionic bond? The ions. We've got a positive ion and a negative ion. What about in water? Like why isn't water a gas at room temperature? What's holding the water molecules together? IMFs. What's the positive thing and what's the negative thing in that IMF? Hydrogen is the positive thing because it's slightly positive, and oxygen is the negative thing because it is slightly negative. Okay, so the positive thing is the slightly, that's a crazy delta. That's not a delta. Slightly positive hydrogen atom. And the negative thing is the slightly negative oxygen atom. And so we might have a little hydrogen here. OH. Do, 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 do. Okay. Now, we have many things happen this week. Friday's a Pro D. Thursday is Terry Fox run, so it's a little bit short. Wednesday, we have our quiz, which basically, if we want to do our lab with the one I handed you out last week, it has to be tomorrow. Or we can put it off till next week. Do you guys have a preference? You want to do it tomorrow? Yeah, let's do it tomorrow. Okay, what that means is that you guys need to make sure that you have done the pre-lab assignment, which I think is here somewhere. So here we have our pre-lab vocabulary. Have you read through this yet? If you have not read through the pre-lab vocabulary, make sure you read through it. So homework tonight. Okay. Let's see what else we got here. Pre-lab vocabulary. And let's see what else we have here. Pre-lab assignment. You're also going to do the pre-lab assignment. And what it involves is read and then on your own paper draw labeled diagrams illustrating each of these safety procedures. So here I've done number 1. Okay, you don't have to be a great artist. This is what I'm illustrating here is you do not need to be a great artist in order to do this. Okay. This one says calcium hydroxide, CaOH2, and its solution, lime water, are bases. Now, I don't know if you remember from last year, but what ion tells you that you have a base? The hydroxide ion. Okay, so we've got the OH ion there. That's a base. And bases are skin irritants. Oh, look. Ow. We have that base on us there. And what do we have to do?
Rinse.
We have to rinse until it feels not slippery. And that's my hand. I think there might be 5 digits on it. It kind of looks like a weird paw or a wing or something, but that's a hand. Yes, and you wash until it is not slippery. Okay, because acids, you'll actually feel them. It'll feel like a stinging, itchy sensation. Okay, and you'll be able to wash until you no longer feel the stinging, itchy sensation. However, with a base, you won't feel anything. It'll just sit there and eat away at your hand. Okay, I don't know if any of you have ever heard of those depilatory creams. They're like Nair or something like that, and they're like sold to women to put on their legs and like get rid of the hair on the legs. And basically, they are just a really strong base. And they eat away at the hair, and they also eat away at the skin. So if you want to like exfoliate quite well, you could use it as an exfoliator also. And then you rinse it all off, and the hair gets either it's like really fine or it like is gone entirely. Okay? So bases, you want to make sure if you get some on, you wash until it no longer feels slippery, because bases feel slippery. Okay, so you're in charge of doing the rest of them. Uh-oh, I didn't number properly. So this is going to, I may have renumbered for you guys, like I may have fixed it, This is from last year. If not, you could call this 5A. If I have renumbered properly, you can go with that. Okay? Slowly and carefully read the pre-lab vocabulary. Add all new words, 6 words to your vocab list. We're not making a vocab list. Okay? You guys already have a vocab list. Yes? Do you remember the one with the pretty pictures? It's long. It's color pictures. Okay, if you've lost it or something, let me know. The solution stuff tends to be towards the end of that package. All right, so that's your homework, that and that. And while we're at it, tomorrow you have your, not tomorrow, on Wednesday you have your quiz. And so in order to get extra practice for the quiz in teams, in the upcoming quizzes and stuff, I've put the extra practice is 5.6A, page 102 to 104, number 23 to 50, if you want extra practice. If you don't feel you need it, you don't need to do it. Okay, but there is extra practice there for your quiz on Wednesday. And right now, we're going to do a mini lab. Mini lab. And we are going to use electronic balances. Good. Okay. All right, so you guys have a calculation to do. And then you're going to do the procedure by following very carefully the steps that are given on the front and illustrated for you on the back. Okay? And this is going to help you with your quiz on Wednesday because this procedure is part of the quiz. Okay? And I'll go get the electronic balances.
Okay, stop.
Balances are being used. You get to use these. Make sure you don't look directly onto the weighing pan or weigh into a beaker. Okay? Once you have your calculation done, come and see me to check your number.
the end is most of you.
So we just need one stuff. What's the model that we got? Five. How do you know? I don't know why you got.
So once you got your number, you can come show me. No, you can come show me, so I gotta put it up here.
There we go. Okay, what you got? Okay. I feel like it should be a 7, but is it a 6-8 at the end?
Yeah.
Okay, then I'm wrong. I'm just trying to remember from last year. Okay. Now, the only thing is that when you look at your procedure, and you guys can all pay attention to this, in theory, we should be able to place the funnel inside, but you don't want to use the narrow one because otherwise the salt will get stuck. Okay, so you're going to use this one and you're just going to hold it in place because it's too big to fit inside. Unfortunately, we don't have a medium in between these two. Okay? All right. So you're good. You got the same number?
Yes.
Excellent. Beautiful. Excellent. Beautiful. Excellent. Did you catch the thing about the funnels? Okay. Those of you who are in line, did anyone not catch the thing about the funnels? You didn't. Okay. Perfect. Good. So, thing about the funnels, those of you who are in line here, okay, don't want to use the skinny one, which fits in because otherwise the salt will get stuck. Unfortunately, we don't have a medium-sized one, so we're going to have to use the one that doesn't quite fit. But all you do is you hold it like nice and tight, like right where, so everything pours through. Okay? Good stuff. And your number is beautiful. 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 Yeah. Good stuff. Yep. Hello. And before I check your number, I'm going to show you guys about the funnels. Okay, so if you're in line, you're going to watch about the funnels. Now, this funnel, if you use this one, the salt will get stuck. It's too narrow. Okay. Sadly, we don't have one that fits in and is wide. So what you'll have to do is take this funnel and hold it. Yes, but it works okay. Like I've never had anyone have a problem with it. Okay, and that looks good. Yep, perfect, perfect, excellent, awesome, good stuff, wonderful. Excellent, excellent. Have you heard my yammering about the funnels?
Not really.
Okay, so the skinny funnel, salt will get stuck. The wide funnel is too big, so what you're going to have to do is hold it on.
Okay.
Okay? Yeah.
Thank you.
Yeah. Hello. That looks perfect. And just before you go,
Yeah.
skinny fat. You've heard all. Yeah, good. Yeah.
You right here, actually.
So yep, into 100 milliliter volumetric flask because that's the volume we want to make. Yep, perfect. Yep.
Where can I get the NaCl?
Pardon me?
Where can I get the NaCl?
The NaCl. Oh!
Yeah, you gotta get out. Yeah.
NaCl is up here. Feel free to take a couple of beakers so you can like take some back with you and then measure it out into the other one. I'll put around a scoopy bottle. Yeah, you can swirl it. Then no, are we talking about that? And how did it explain to you? Hannah, you don't know either.
I mean, like, I've been thinking, like.
I said, did you hear about the funnels?
Yeah.
And you said yes.
It's the.
Yes. Okay, so this one's too skinny. This one is too wide, but you have to make it work just by holding it.
Okay.
Okay? Yeah.
Yes, we already have it.
Yeah. He just didn't know that you had to hold it. Yeah. Good stuff. And do you know about the funnels? This one's too narrow. The salt will get stuck. This one is too wide, so you'll have to hold it on. Okay?
Like, I see.
Return any salt that you don't use. Use pork. I guess the rain over the weekend got into the fume hood and made my box a little damp. Oh well.
Oh.
Oh, yeah. Oh, we don't.
Yes. Don't miss step numbers 3 and 4. And feel free to use the pictures to help you out.
Wait, what do we need on I don't know how she hunting that on the playground.
Did you place your salt directly on the beaker, on the pan?
On the scale.
Told you not to do that. I told you to put it in the beaker. But oh well, we're done now. It is easier, but it makes a mess of my pans. Yes?
No, we just go to the scale and measure 4.68 grams of salt.
You guys are going to find that you have so much salt to bring back because like 4.68 grams is not actually that much. You're going to be like, why do I have so much? But it's okay. Just take it. Bring back any salt that you have not used. Okay, we're gonna pop it into here and I'll go grab other angles. Okay. I'll still do one of those. Oh, okay. Yeah, that's good. This is right.
Yeah.